There we go, we are live. Okay, today is review day. So it is 1/7/2020. Okay, so number one, graph the point -3, -8, and convert this point into a polar form. So I'm going to get out my graph paper. As I do this, it should be easy. We did one like this on the warm-up. So I take my point, and it's going to be at -3, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw it in, okay? So what I want, if I'm going to go ahead and get it, polar points are in the form of r comma theta. Okay, polar points are in the form of r comma theta. We know our radius is the length of the pole, and my angle is from 0 all the way around. Okay. Now, let's find the radius first, just using Pythagorean's theorem. So r is going to equal the square root of -3 squared plus a -8 squared. Sorry, it's sloppy. So r is the square root of 9 plus 64, which is the square root of 73. Okay, and the radius is always positive because it's a length. Okay. Now I need the angle. So what I'm going to do is I'll probably find, if I find this angle here, right, call that theta, and I'll just add 180 to it, right? So I'll make myself a little right triangle here. And if I look at my little right triangle, this length was 8. I'm just going to call it 8. Yeah, it's -8, but I'm going to call it, we could call it -8, but I'm going to call it 8 and 3. And if I want to find the reference angle, remember that term, reference angle? I'm just going to use tangent, right? I've got opposite adjacent, so I'm going to go tangent of theta is equal to my...
Isn't a tangent inverse?
Yes. Yes, in order to get the angle, I'm going to make it the inverse. You're totally right, Landon. So for right now it's just tangent, but if I want to find the angle, I'm going to change it to tangent inverse of 8/3 gives me theta. Yes. So...
Wait.
Hmm?
What mode is it in?
Yeah, great question. So if you put in radian, it's not wrong. I'm probably going to go degree mode, okay? It doesn't matter. You could do it in radian mode, but I'm going to do it in degree mode just because degrees are going to be easier for you guys to understand, right? Agree with that? But we know we get both angles, okay? So check my mode. I'm going to go degree mode. So let me go back and change my degree mode. Quit. So tangent inverse of my 8 divided by 3, and I get an answer of about 69.4. So theta is about 69.4 degrees, but that's not my full rotation. So I add the 180 to that, so I get my full rotation plus 180, and I get an answer of about 249.4 degrees. Okay, so then my answer is radius, square root of 73, and angle, which is 249.4 degrees. Okay. There you go. Thumbs up. Can you do that tomorrow? Awesome. Okay. Number 2. Am I going too fast? Okay. Number 2, we want to change it to rectangular form. So I'm going to fold my paper up. Okay. So again, if I make a graph of this, let's see. Make a graph of this. 5π6 is actually on the unit circle. 5π6 is here, so a -5π6 would be here, okay? 5π6 is here, this rotation, -5π6 is here. So if I graph this, it's really right about here, okay? So my angle is at a -5π6. My radius is 4. If I want to convert it, I'm going to change my calculator to radian mode because of the pi's, right? And I'm going to go x equals 4 cosine of -5 pi 6, and y equals 4 sine of negative 5 pi 6. And I'm just going to use my calculator. Here, radian mode. Enter, quit. 4 cosine of negative 5 pi 6. And I get an answer of negative 3.46. And I'll do the same thing. 4 sine of negative 5 divided by 6. Divided by 6. Okay, and I'll even show my calculator so you can see. See, I'm putting in my calculator, right? Enter. And I get negative 2, okay? So I get negative 2. So as a point, because it's a point, right? I'm going to rewrite it as a negative 3.46 comma negative 2. How am I doing? Am I going too fast? Okay. Remember, this is for you, not for me. If I get going too fast, tell me, okay? I can handle that. I won't get offended. You have not been doing math for 35 years. Only I got to add in my high school days. So I've been doing math my whole life, okay?
You've been in school literally your entire life.
Yes, but you know, that sounds depressing, but here's the good news. You know, here's the good news, though. Think about this. I've had summer vacation my entire life.
Yeah, but for real.
Not many people can say that. I love it. Okay, number 3. So I want to convert. So I've got to have the conversions a little bit hard. So to do the conversions, I should definitely have some things on my. So I know that x squared plus y squared is equal to r squared. That'd be a good thing to have in my notes. I know that x is equal to r cosine theta and y is equal to r sine theta, right? I could also take this and say that r is equal to the square root of x squared plus y squared. Okay, so if I want to convert, I want to get rid of the r's and the thetas and get x's and y's only, okay? So the first thing I see is I can put this square root of x squared plus y squared, I can put that right there, okay? And then I get rid of r's, okay? I want to get rid of r's. And the second thing I can do is I can put, instead of cosine theta, okay, cosine theta is equal to my x over my r, and my sine theta is the same thing as sine theta, same thing as my y over my r. So let me make some substitutions, and I'll go from there. Okay. So instead of r, let's write square root x squared plus y squared. Okay. So I wrote, instead of r, I need x's and y's. So put that there. Okay. Equals 2. Okay. Now the next thing I'm going to do is, instead of cosine, let's write our x over r. Right. And instead of writing, now cosecant, what's cosecant going to be? Well, cosecant of theta is probably going to be r over y, right? Oh, I forgot the cosecant. Does that make sense? So let's rewrite this as r over y. How am I doing? You okay with that little flip? Since I need a cosecant, I just change this to r over y. Now, what do you see? Hopefully you see something magical. What do you see? Yeah. Now, before I simplify it, are there any thetas or r's left over?
No.
And it's all in x and y's, right? That's our goal. So my answer is the square root of x squared plus y squared equals 2x over y. And that'll work. Now, here's the thing. This is why we do polar, because you can't graph this. This is a mess, right? But you can graph this original equation and know what this looks like. Isn't that cool? The shape of this graph is whatever this gives us. And we can graph that on a calculator, which we will later, okay? Okay, now, graph. Theta equals 5, 6, and convert to rectangular equation. Well, graph that. Well, okay. All right. Well, let's see. If I go to my polar, I don't want this to be too confusing, but you're going to do this. I know you're going to go to your mode, right? You're going to go polar, okay? Now listen, I'm going to go straight to y equals. This is theta, not r. So we got to think. We got to think. I'm going to do this one. I can't graph it on my calculator. But what do I know about the angle 5 pi 6? 5 pi 6 is here, isn't it? Right? So my graph looks like this. Right? That's my graph. And the reason it's a line is because the radius is constantly changing. The angle doesn't, right? So it becomes a line. The radius is variable, but the line isn't. Okay, now, if I want to convert this to y equals mx plus b, it's a straight line, right? So then I know the b, 0. So I can go, okay, y equals mx plus b. But I want to find the slope of this line. So how would you find the slope of this line? Well, let's think about this. I know the slope of this line is rise over run, right? Tangent of an angle is y over x, which is rise over run. So the tangent is also the same thing as the slope. So if I take the tangent of 5 pi 6, I'll get the slope of this line. Okay, I'm just going to do that. And I'm probably going to be in radian mode, correct? Well, luckily, I don't even need my calculator because I know the tangent of 5 pi 6 is negative square root of 3 over 3. So now I know my slope is negative square root of 3 over 3. So the equation of this line is y equals negative square root of 3 over 3x plus 0. And you don't need the 0. I just put it in there anyway, okay? How's that? A little confusing, but not too bad? Okay, number 5. Oh, the fun graph. Well, let's make a flower, okay? Okay, if we're going to graph this, let's think about our window. Let's be smart about our window, okay? So if I'm going to graph 5, if I'm going to graph r equals 5 cosine 4 theta. So first of all, a couple of questions. If I go to my mode, okay, so if I go to my mode, we got to go to polar. You guys agree? Now, here's the next big question. This is really important.
Polar?
Are you radian or degrees?
No, because it's radian.
If you go radians, and radians okay, then when you do your steps, you're going around a circle, correct? So if you go radians, you're going from 0 to 2 pi, okay? If you go degrees, you're going 0 to 360. And it does not matter, but you've got to know that. So,
Let's do degrees.
okay, degrees seems probably easier. Okay, we'll go to degree, enter. We'll go to y equals, which is now, and I'm going to go my 5 cosine 4 theta, right? With me?
Wait, so, but I don't understand how you get to the R's.
Yeah, so did you go to your mode,
Yeah?
change it to polar.
Oh,
Once you change it to polar, you'll get your R, okay?
okay.
So now, we decided to go to degrees. So watch this. Go to your window. Make sure you guys, so if you're going to go your mode, and if you want to do, you've got to go polar mode, and then if you decide to go degree, which degree is okay, then when you go to your window, okay, you ready? Here's the biggie. When you go to window, all I'm going to see is 6 degrees. My calculator's stuck in radians. Does that make sense?
Oh.
Now this is important because my calculator thinks I'm in radians. That's 2 pi, right?
Mine doesn't.
Which is the 0 to 360?
Yeah.
Okay, good. I need to change mine to 360, don't I? Okay. So we change mine to 360. 360. And it's like the strobe light. I want to see every 1 degree, not 10. 10 to take me forever, okay? So I'm going to make my steps by 1. So I'm going to graph 1 degree, 2 degrees. So I'm going to graph 360 degrees. So I'm going to go my steps by 1. Minimum. I know it's a flower. I do, and I know it's going to be a flower of a petal length of 5. Path length 5, so I'm going to go probably negative 6 to 6, so I see all of it, right? And I'm going to go scales by 1, negative 6 to 6, and then I should be able to graph it and see a pretty flower. Okay, ready? You ready for me to graph it?
Yep.
Here we go. Ooh, pretty. Now, if you don't get this figure, then something's messed up, right? Look at that. Isn't that beautiful?
Oh, mine does not look like that.
Okay.
Wait, look at this. Why?
Let's go negative 7 to 7. Negative 7 to 7. Let's check mode. Let's go to green mode. Why am I going to green mode?
I thought I was already in.
No, it wasn't. So now if we grab it, we're going to get it. Okay, everybody good?
Jamie,
Yeah.
can I buy you
Okay, so we know it's 5, so negative 10 is going to work. Let's check your mode. Okay, that should work. That should work. Yeah. There you go. Yeah, okay. Sydney, what you got? Okay, now max. Let's go negative 6. We might have those backwards. Let's go negative 6 plus
Wait, what?
3, right? Because you went 0, 3, 6, 8. Let's grab it.
Oh, yes. What the freak? Yes! We have had to struggle.
Get a 0 out of 8. Does that make sense?
Yeah.
Okay, moving on. Everybody good? Okay, so 7. 7's easy. All we're going to do is I'm going to take a ruler. Let's measure this. Here's V.
Skip 6?
Oh, no, yeah, yeah. So I'm doing 6. Sorry, Landon. So I'm going to measure. I got about 4.5 centimeters. And W is about 5 centimeters. So on a blank piece of paper, I'm just going to draw it, okay? So draw V plus W. I'm going to draw the head. Remember when we're out in the hallway and we're dragging Landon around?
What?
So let's do that.
Can we do that again? I don't know.
Skyrim.
Yeah, Sky and Landon and Morgan were doing it.
So, sorry, Zoe, you missed. So I'm going to draw this head to tail is the easiest way to do it. So I'm going to redraw V. Okay, I'm going to redraw V. Same direction, 4.5. So I'm just going to copy V down. There's V. And to add it, I attach it, and W is 5. So by adding them, I attach it, because it's like a journey. I go from here, then to here. The resultant, you must put in the resultant. The answer is here, right? That's the resultant vector. That's when you add them. That's the two forces acting. Where is the actual airplane going to go? There. That's your V plus W, okay?
Wouldn't the 5 be going the other way since it's positive?
It goes this direction, right?
Mr. David,
We're going to make it go the other direction when we subtract it. We're going to go, yeah,
what were you doing for like the 2 minutes?
for the 2 minutes.
For like 2 minutes, what were you doing?
Oh, what do you mean right now?
No, like you stopped teaching for like 2 minutes.
I did?
To make sure the calculator goes.
Oh,
Oh, yeah, I was going around checking everybody's calculator.
Oh.
So
So
it's
did
two.
we answer number 5?
We're on.
Yes, we graphed number 5. Yeah, it's right there.
That's all you had to do?
That's all you do is just graph it.
Oh.
And we sketch that out.
And just sketch that out, yeah. Yeah. Okay, 8. Or I'm sorry, 7. So 7, what's the difference? What's 7? We're going to take V, and W goes the opposite direction. That's all. So I'm going to take and draw that. Let's see, where did my picture go? Okay. So I'm going to draw. No, you weren't here. It's all good, though. We'll try and get you caught up. So I'm doing 7. I just measure it with my ruler. Okay. So I'm going to do V minus W. So I'm going to do my V, which is a length of about 4.5. There's my V. And if I'm going to subtract W, it's like a push instead of pull, so it goes the opposite direction. So it's going to go like this. I'm off my paper, but that's life. That's the way it goes. Okay, so instead of going down, I went up. So when you add or subtract them, you attach it. First force, second force. The resultant is from beginning to end. And there it is. There's my V minus W. Okay, that's not too hard, right?
Can you show number 6 again really quick?
Yeah, if I can find it. Here it is. Here's 6. There's 6 right there, okay? So I just drew V exactly the way it is, and I drew W exactly what it was, except for I attached them, right? I just attached them. And then what I did is made my result vector. Now, we actually need that for number 9. So 9 says find the direction of V plus W. And probably the magnitude. I'm going to want both. I'm going to want the magnitude also. And the magnitude is the length of V and W. So let's take a look at this picture, okay? So the direction, okay? All right. So my magnitude is the length, right? Okay, so let's measure it. It's about 6.9. Okay, I'm just measuring it. So the length of this is about 6.9 centimeters. If it was a force, it'd be like 6.9 pounds. If it was a speed, it'd be like 6.9 miles per hour, whatever it happens to be. And the direction is this angle here, protractor. Sure. So here's my V plus W. Here's my result. So if I want the magnitude, I just measured it. Just took my ruler and I just measured it. Okay? And then if I want the direction, I'm going to use my protractor. And I'm going to estimate it to be about 332 degrees. I just measured it. I used a ruler, measured the length, and I used my protractor. And watch the protractor. Here's 0, okay? 332 is what my protractor says. It's kind of hard to see.
Yeah, kind of really.
Yeah, but it really is about 332. If you get right up here, there's 330 right there. Okay.
But that's the direction.
That's the direction, yeah.
I can afford to.
Okay, now.
So, wait, so theta 332 is the direction of it?
Yes.
Okay.
Yes. Okay, now, 10. I like 10 better because I can graph it. And that's why we put vectors, we change them to rectangular form because it's so much easier if you can graph it. So 10, okay? 10's like one of our problems on our warm-up. Okay. Well, we already did 7, 8, 9. We really did. Hold on. 8 was...
I have no idea. Did you do 8?
Yeah, 8 we drew it, right?
Well, what, is it just that right there?
Right.
So we drew it in number 6.
Yeah, so it's a little messed up. That's because I modified this thing.
Oh, okay, you're
Yeah,
good.
yeah.
Sorry.
Okay, you guys ready for 10?
Yeah.
Okay, so this is the one Emma did. Right, Emma? You can do this. This is the problem that Emma did, okay? So, let's go 1, 2, there's A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There's B. Okay? Now, a vector equation Okay, a vector equation is going to be like your parametric, okay? So the vector equation, let's put it, first of all, to the original, okay? So we'll make it into a component. So we'll take it and move it to the origin, okay? For me, it's easier just to do this. It's so much easier for me to go 6 minus 1, 7 minus 2. It's easier to move that way. Then if you want to just pick it up, move it, you can. So I'm going to go to 5, 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 5. It's the exact same vector, but it's been moved to the origin, right?
How many did you go up?
I went 5 and 5. Yeah. Now, how did I get it? I subtracted my x's. I subtracted my y's. x2 minus x1. So I did my x2 minus my x1 and my y2 minus y1, okay? So a vector, my component vector is 5, 5. It's the same vector, same direction, same length. Same vector, same direction, same length, except for now its component vector starts at the origin, okay? Okay, now, the velocity is its length. The velocity, if this were speed, the velocity is the magnitude.
Isn't it just 5?
It's the square root of 5 squared plus 5 squared. Right? Pythagorean's theorem, which is the square root of 50. Square root of 25 plus 25, square root of 50. So my speed, or my velocity, is the square root of 50, okay? Now, let's make it into a parametric. Okay, so make it into a parametric. Let's look at the original AB. So parametrics go like this. Parametrics, x of t, y of t, okay? Here's my parametric. Oh, I guess I can do my parametric down here. I'll do my parametric down here. X of t, y of t, okay? Now, to do a parametric, let's take a look at the original, okay? Parametrics are all about the x's and the y's. So first of all, take a look at the starting point. Only think about x's. What's the x value? Starting point, what's the x value? 1. And then it's going to move horizontally 1, 2, 3, 4, 5 over, right? So plus 5t. Look at the y's. What's its starting y height?
7?
2. And then
Oh yeah, you're right.
and then we got to go up 1, 2, 3, 4, 5 plus 5t. So the bug is going to move simultaneously. The bug starts at 1, 2, right? So it's at 1, 2, and it's going to go over 5, up 5 to get to here. Now, where's the bug in 8 seconds? Well, that's pretty easy, actually. So to do 8 seconds, just let t equal 8. I can do that. Just plug it in, right? So I'll have a x of 8 is equal to... That's part of the question.
Oh, okay.
It's all good. Is 1 plus 5 times 8, and y of 8 is 2 plus 5 times 8. So just plug it in time, 8 seconds, right? So I get a 41 and a 42, so the position would be at 41, comma 42. So the bug's running along. Starts here, moving along, and after 8 seconds, that's where the bug is. So if we want to squish the bug, we got to be standing right there to squish the bug when it runs by, okay?
No, we do not have some more tonight.
Probably not, but I put it on there just in case, right?
For A about a problem, the answer would be...
For A,
Yeah.
it's the 5, 5. The answer for A is 5, 5.
Okay.
Okay, now, turn the page. Okay, now, okay, convert this equation to a parametric equation, all right? So, here's what we have. You cannot graph this. You can't graph this. So if you do take calculus, there's some problems that you can't graph. You cannot graph this because of the y cubed and the y squared. However, you can do it in parametric. The way you do it in parametric is this. You start with, so you got x equals y cubed minus y squared minus 6, right? So what you do, though, is you let y equal t, okay? So parametric equation, you let y equal t. Parametric equations, you got x of t, y of t, right? Parametric. So I'm not going to write y's anymore. I'm going to write t's. So I go t cubed minus a t squared minus a 6. And we already know y is equal to t, right? Well, why in the world would we do this? Well, I'll show you. I want you to see this. Because if I was sitting in a calculus class and I went home and I want to do my homework, and if I could see it, I can do it. That was really the way I was. I mean, I'm very visual. So I would go home and I would come back from my college class and I would go straight to saying, I don't know what the heck this thing looks like, but I know if I change this to parametric and I'd go to my y, clear, and if I graphed in, ready, a t cubed minus a, go back, delete, minus a t, doggone it, quit. I'm messing up. Y equals t cubed minus a t squared, subtract 6, and y equals t, okay? And then I'd go into my mode, or my window, and made sure that 0 to 4 seconds is plenty to see it. Remember? I could even go negative seconds if I want to see more. Okay. Steps by 0.1 works. Negative 6 to 6. We'll see if this is enough. Okay.
It's not going to work.
If I graph it,
But you can't see the
so I need to see more, right? So I go back to my window and then you see more. Probably need to go more back on my y, so maybe negative 12 on my x's. Let me see, graph that. Oh, there we go. And that's what it looks like.
Would it be radian though?
It won't matter. You know why it won't matter? I never use sine or cosine
Oh, okay.
or tangent, right? Yeah. Great question. Only when you have to push those 3 buttons does it matter.
Wait, what's the
Only
window?
time.
What's the window?
Yeah, I'll show you my window. So I can go back to my dorm room in college, and I can graph it, I can see it, I can do it. Makes me happy, okay? Okay, now, 12, all right? The big problem, but this was not so bad. So we need these equations. Luckily for you, I wrote them down, okay? Football is kicked with initial velocity of 45 feet. That's V0. And an angle, that's theta 45 degrees, okay? So, parametric, x of t equals my 45 cosine of 45 degrees t. Y of t equals 45 sine of 45 t minus 16 t squared. Okay, there's my parametric. Piece of cake, right? Got it. Now, what is the distance and height of the ball after 1 second? Well, I'm going to have to graph this. You guys agree? So I better graph this. And so when I graph this, a couple of things, okay? Let's graph this. So first of all, let's go to our mode. Now it does matter, doesn't it, right?
It's degree.
Yes, it has to be degree. It does matter, right? Because we're going to push sine or cosine. So we're going to go to parametric, paramode, and we're also going to go to degree, right? So I'm going to go to my mode. I'm in parametric degree. Everybody agree? Then, the second thing I want to do to graph it is I got to use some common sense, okay? I'm just going to kind of think about it if I graph it. I mean, you've always been to a football game, right? I assume. So think about this, okay? It's in terms of feet, right? But, all right, Ben, you never kicked field goals, but you got the idea. I mean, really. So go to my window. And if I go to my window, come on, you guys. kick the ball. How many seconds? How many seconds in the air?
5.
5 sounds great. 5, 4, doesn't really matter. But if you put 100 seconds, the ball is going to be laying on the ground for a long time, right?
How
Okay.
many seconds?
100. The cheerleaders going to be doing their thing still for, a long time. I like point ones. Remember, it's like the flash. If you go 1 second, then the lights are off and you see the ball. Then the lights are off and you see the ball, right? So I like 0.1 seconds so I can see it. Go right? 0.1 seconds. On mode. Minimum, probably 0, right? Because it's not going to be negative. How hot? Now how far do you think the ball's going to go? X max.
35.
Okay, 35 feet. Now 35 feet's only like what? About 10 yards,
Wait, 35 yards.
right? So 35 yards would be about 100 feet.
Okay.
You okay with that? Okay, 100. Okay. How high up do you think it's going to go? 0. Whoops, 0. How high do you think the ball's going to go? Well, if it's a 45-degree angle, give me an idea. How high? Come on, the ball is going up in the air. How many feet up in the air? You can be wrong, because we're going to graph it. If you're wrong, we just adjust it. How high? Let's go 45. Evan says 45
No,
feet.
25.
25?
Did you say 25?
Yeah. Have you seen the TikTok?
Okay, Evan says 25. And let's graph it. Boom!
Oh, shucks.
Hello, love. Would you like to ride my troll leg?
Oh, that is a sad kick. Right?
All right, I go equals. Oh, I got the wrong thing in there.